Hello again and welcome to another episode of Simply Electronics. Now, as you've just seen, we're going to be using high voltage in this video. So I would advise that if you're not experienced with working with high voltages, that you stay clear. Basically, we're going to make a rectifier, a very basic rectifier circuit, so there's not going to be any step down voltages. So basically, this is just the live and neutral line here. And I've got it connected to my multimeter so I can measure the AC voltage. So the other end of this cable just goes to a plug which goes into a power socket in the wall. We're going to make a rectifier. If you haven't seen my previous video, I did quite a visual demonstration of how a rectifier works. And a rectifier will basically turn alternating current, also known as AC, it will turn it into direct current. So that's what we're going to do today. But we're not going to step down the voltage, we're going to keep it high voltage just to minimize components. This is purely just to show you how a rectifier looks in real life versus a simulated circuit. So you can see now on the screen, here's a schematic for a rectifier circuit. You can see the diodes are configured in a certain way where AC goes in and DC comes out. So if you haven't also watched my previous video, where we talked about the differences between AC and DC, I definitely recommend you go and watch that first, because there might not be any point in seeing this if you don't actually know the difference between AC and DC. Without further ado, let's go ahead and I'll plug this in just to show you. So currently the multimeter is set to measure AC voltage. So currently it's measuring about 237 volts. So this is 237 volts AC. If I touch any of those wires or any metal contact that might be exposed while this AC voltage is live, that could absolutely kill me. And certainly if it doesn't kill me, it'll certainly hurt very badly. I have experienced full AC mains shocked before, and trust me, you don't want to experience it. It's a pretty bad feeling. You definitely want to be aware of your heart rate and your heart rhythm after you've been shocked, because while a shock can hurt at first and you might realize you're not dead, it certainly can kill you afterwards. Say 10 minutes later, it can actually cause your heart to go into ventricular fibrillation, which means an erratic heartbeat, which can eventually kill you. So now that you've seen that I have 237 volts AC on this multimeter, I'm going to disconnect the plug so we can work with these cables again. Okay, so my multimeter is saying there are 0 volts on here now, so now I can touch the wires. The wires are no longer live, there's no voltage on there now, so I'm safe. So we're going to make a rectifier circuit. So I'm going to build this circuit on a little bit of perf board. So all we need to make the rectifier is 4 of these diodes. These are 1N4007s. They're designed to work up to 1000 volts. The total current that can pass through these is 1 amp, but we're not going to be passing any large current through them. So we don't need to worry about that. If you recall the rectifier video, there is a certain configuration that these diodes need to be in. So we're going to rough this up on the perf board by putting our diodes in with the same configuration. And again, the reason why I'm doing it like this is because it keeps the circuit simple. And we will be rectifying the full AC voltage, but what you will usually do if you want to actually power something from this is you would also use a transformer before the rectifier to step down the incoming AC voltage to a smaller AC voltage that you would need, and then the AC from the transformer would come through the rectifier and DC would come out at that lower voltage. But because this is just for demonstration purposes, it just makes it a lot simpler. Transformers, by the way, we will be covering that in a future video. So those are my diodes in position, and what I need to do now is just solder them in place. Connect them all together. Okay, so those are soldered in place. So now we just need to cut the legs off. We've got our diodes now soldered in a configuration that will turn AC into DC. You can actually see the diodes have two sides to them. There's a black side, and then there is a sort of silver strip on the end of each diode. The silver strip indicates the cathode, and the cathode is basically the negative side of the diode. So the black side is the positive side, otherwise known as the anode. Okay, so the way that they're configured, we input AC on two corners of this rectifier, and we then get a positive and negative DC voltage out on another two corners. Okay, so we've got our AC connected up now, and the DC output works like so. The positive of the DC exits where the two diodes have the cathodes pointing towards each other. So these two diodes here, their cathodes are both pointing this way. Okay, so they're pointing towards each other. That's where our positive DC comes out, and the negative DC, the negative side, is where both of the black points point out to each other. So we've got them pointing this way, and obviously then the incoming AC goes on the two remaining sides. Okay, so if I now go ahead and measure the output of this rectifier, you can see there is a bit of a voltage drop because of the resistance of the wires and the diodes. DC, we've got 212 volts DC, bit of voltage drop across the diodes and the wires, but there we go, we've got our DC. There we have it. We have AC coming in here, and out of the other end of the diodes we have our DC voltage. So that is how a rectifier works. I'll be covering transformers and lots of other different things in the near future, but yeah, I just wanted to show you an actual a rectifier with these four diodes working in real life. Yeah, so don't go killing yourselves with this high voltage. Make sure you stay safe. Leave a comment below if you have any questions or any suggestions. Leave a like on the video and definitely subscribe for more videos.